after that to continue this, right? Okay. So this is our mixtures part 2. Mixtures part 2. Tute. Right. Let's go through this and see. Our very last part was preparation of solutions. How to prepare a glucose solution, sodium hydroxide solution, how to prepare a copper sulfate solution with known concentration. Preparation. Today, separation. Separation. From a mixture, how to separate components. How to separate compounds. What are the techniques? Page number 19. Separation of compounds in mixtures. And there are how many separation techniques? 8. One by one we discuss all. That's the end of this unit. 8. First one, mechanical separation here. Second one, vaporization, evaporation here. Third one, filtration here. Fourth one, crystallization. Then after crystallization, fifth one, recrystallization. Sixth one, solvent extraction. Seventh one, simple distillation, fractional distillation, and steam distillation. Page number 23, 7.1, 7.2, and page 24 same, and page 25 7.3, all are distillations. Then page number 26, last one, chromatography. Paper chromatography. That full page is chromatography, paper chromatography, right? Then under these techniques there are some real applications. Page number 27, uses of separation techniques. First real application, extraction of salt from seawater, salton. This year than last year. Why? I have printed more things and you have to write less than last year, because every year we are getting new O-level paper to our syllabus. We need several hours to discuss that also. So amount of writings I decrease, right? Questions I don't reduce. When new paper is coming, I don't remove old questions. No, old questions also we do, new also. So here less to write this year than last year, right? Page 28 also same. Page 29, our last one, our second practical application, the real application, essential oil extraction. Then let's go through past paper section to see whether this is important or not. Page 30, MCQ questions. Take your tute. Page 31, long essay question, calculation type, and another essay question. 32, one long question, salton. Page 33, yes, long 2 questions. Page 34, new syllabus questions, 2017 one, 2018 one, very long, right? Page 35, 2019, 17, 2025 March, MCQ, and last page, 2025 March, mein ye period aave, it's essay question. Below that, last year essay question. Last year also came, this year also came, previous year also came, and next year also for you will come, right? Surely some questions will come, sure, right? Last page same thing, and 2022 question, that means 2023 came in 23, 24, 25, 26 also, sure, right? And the thing is, we all can answer if you are ready. If you are ready, can answer, can get full marks for this question also. Right, so let's start from 19 then, right? Page 19, separation of compounds in mixtures. Separation. Is there any other Muslim students here who had festival last Monday? Please raise hand. I think no one. You? No. All right. No, we had to do class. So for them, I am going to give them free link. Very reasonable, right? We should do that. We should cancel our class, but we couldn't cancel. We are late. There's a long syllabus. So if there are any your friends, tell me. We'll get from admin free link and give them. Right? We should. Right. Okay. Right. Where is our picture box? Because I have to show all these separation techniques. Right, so today also as usual, we use time very efficiently and effectively. Understand, remember, record, put everything into your head, right? Now itself, in the class itself, then it's nothing. Right. Okay, right. So this presentation, what are you eating? Papadam? I can hear papadam noise. Papadam podi, you know, right. Girls, boys, you eat lot of bites, ne? Maybe every class, bite packets, ne? I have heard that, and yeah, it is said that it's not a secret. When some people produce bite packets, they put bottles like this, Coca-Cola bottles, Fanta bottles, plastic bottles. Some producers, it is said that some bite producers add plastic bottles to give that yes, that kara sound, that texture, and to increase its like, I can't say quality, because it should be healthy first of all, ne? Like its texture, durability, everything. So be careful. Ne? It is said that they use plastic bottles, right? Then plastic bottles melt and plastic becomes liquid. It mixes with your food. Be careful. Ne? Good bites can't not anything with an. We don't know what do they add. But many people say they do it. Maybe not all, but we don't know who. Right. So there are 8 separation techniques. First one, very first one, mechanical separation. Give me another word for mechanical, starting from P. It was in food digestion also. Yeah, I got to know that no, it's grade 10, right? I think grade 10. No, grade 11. I got to know that our second grade 11 extra class recording, excretory system and blood system, had not been uploaded to website, and I informed the admin. Now it is there. If anyone wants to join, can. Second extra class. Right. Mechanical separation. We have a mechanical digestion process also in our digestive system. It's called mechanical process. What else can be called? Starting with P. Papadam digestion. What? Come on, will I know? Mechanical process is called. Okay, next one is chemical process. Mechanical process, chemical process. So mechanical process is called physical process also. So this mechanical separation is a physical separation method. Actually, there are many physical, mechanical separation methods here. Let's go and see. Physical, that means we don't use any chemicals. There are chemical separation methods also here, but all these are physical. Let's go and see. Mechanical separation, so no introduction. Mechanical separation means physical separation. Without using chemicals, we can separate. Can you remember which kind of things can be separated by physical methods? According to grade 10, unit 16. Bite packet එක බෙදාගන්න බැරුවද කතා කරන්නේ? මම දන්නේ. Grade 10 unit 16 had 3 separation principles. Highly reactive metals are extracted by මොහොම කිව්වනේ electrolysis of fused chloride. Moderate reactive ones, reduction method. Less reactive, low reactive ones, physical methods, right? Physical methods, physical techniques. So here also once again we meet physical techniques. First one, winnowing. I am going to show this. First one, winnowing. So, if you see, you can link what you have seen already into this. No, isn't it? If you can see these techniques, then you can link what you have seen. Switch එකක් නෑ නේ ඉතින් එහාට. හැබැයි මේක off වෙන්නේ. Right. No, didn't come. First techniques are very simple. You have seen. Maybe you don't know the English name, that's it. Or maybe you don't know the Sinhala name, that's it. Here they are coming. Balanced? Okay, ne? No, I didn't want to show those two persons. Look at what they are doing. This is called winnowing. What is it? In Sinhala, what do we call it? Polanawa. Kila කියනවානේ. පලනවා නෙවෙයි. පොළනවා. පොළනවා. Kulling polanawa. Winnowing is this. So look at this one. When they do this, what happens? Good paddy seeds which are heavy, which are dense, cannot stay in this container, in that, and less dense chaff, paddy, husk and all, they have to go out. So we use here density difference. Dense substances stay inside this, less dense substances have to go out. That's the technique. Isn't it a physical method? Physical method. Density belongs to physics, right? So winnowing, removal of chaff from rice, difference in densities of the components used there, right? That's it. Second mechanical separation technique, sieving, removal of gravel from sand. This one is a demonstration. This is a wooden frame with handle and there is a wire mesh here, net here. A small sand particles smaller than the holes of it can go down, large gravel can't go. So, what is the method used here? Method is this. What is the principle used here? Technique. What's the fact used here? Differences of sizes. Small particles can go, large particles can't go. So, isn't it physics? Physics, physical method, mechanical separation. So, there are modern instruments. This is a very simple, very old, primitive one, but you can understand. Sieving, removal of gravel from sand. Gravel from sand or sand from gravel? Okay, no? We want to get very fine sand, especially when we plaster these walls. We have to apply a plaster, very soft cement layer. For that we have to do this one. With gravel we can't do that. Right. Difference in the size of component particles used. This is called sieving according to grade 11. If you check grade 9 textbook and 11 book, there are some problems. This is grade 11, we go with these words. Right. Next one. Sifting, removal of sand from rice. Sand from rice or rice from sand, whatever. Right. Sand from rice. This one. Sifting for grandmother. ආච්චිට හාල් කරනවා. නේ? Sifting for grandmother. Grandmother or grandfather. නේ ආච්චිට හාල් කරනවා කියන්නේ හරි. ඕක තමයි ඈ. Sifting. So in sifting what happens? Please come, take your tute and go. Tell them සද්ද කරන්න එපා. සද්ද කරන්න එපා. සද්ද කරන්න එපා. හරි. We put paddy seeds into this and we put water and we do this sifting. Then what happens? Dense stones go to the bottom less dense paddy seeds with water can stay in the top part, and we can take little by little out this paddy seeds. Stones have gone down, sifting. හරිද? බර වැඩි ගල් කැට වැලි කැට ටික පතුරට යනවා, බර අඩු හාල් ටික උඩ තියෙනවා, එළියට ගන්න පුළුවන්. Right, sifting. Let's read. Sifting, removal of sand from rice, difference in densities of components we use here. Right. Next mechanical separation method is floating on water. Floating what? Floating. Tell me good seeds or bad seeds. What's floating? What do you think? Which seeds are floating there, good or bad? Bad seeds. Why? Mostly those seeds are empty. Insects have taken the juice out from these, not after formation of seed. During formation, there is a milky solution state inside the seed that is taken out by. Actually, insects come and pierce and suck this juice. Therefore, these are empty seeds, they float. So, we put water, we put seeds into water like this. All the floating seeds we collect and throw. Of course, most of them germinate. At least some of them grow, germinate, but they are going to give very weak plants, very weak seedlings. We don't take. Okay. After collecting and throwing, we can see they grow. We think, aparade, in vain we have thrown. Ne? No. They are growing, but they are giving very weak plants. Good ones are not here, good ones are at the bottom. So, floating on water, removal of dud seeds from seed paddy, like empty seeds from seed paddy. Difference between the densities of components and water we use here. Okay, good seeds are denser than water, bad seeds are less dense than water. That's the technique. Next one, directing into stream of water, separating gold from ores. Difference in densities of components used. Right, what's the method? Directing into stream of water. Look at this. We direct strong pressurized stream of water into this ore where gold particles are present with sand particles, mud particles, humus, various minerals. Gold particles have the highest density, so gold particles are not going to get washed away. Gold particles stay in that area, and mud, organic matter, light particles get washed away. Then later we can take this soil and carefully we can try to separate gold. Right. It's a physical method, directing into a stream of water, right? Separating gold from ores. Ore means the soil which has something really important for us. Maybe iron, maybe gold, maybe silver, maybe gems, something. Right. Difference in densities of components used. Dense gold particles stay, less dense other particles go away with water. The last one, magnetic separation. Magnetic separation. Separating certain minerals from mineral sand. Magnetic property of the components used. Okay, mineral sand has various mineral particles. Some are magnetic, some are not. If you want to separate magnetic particles, we can use this method. We grind that ore into a powder and we convey on this belt, and at the end of this belt, this mixture has to fall down due to gravity. But we use some magnets in this roller, therefore, while falling down, they are pulled towards the magnets in this roller, therefore, they fall somewhere here, and non-magnetic minerals fall here. We can separately collect this and collect that. It's a simple technique. Okay. At the end of the belt, they all have to fall down, and this roller has some magnets, therefore, this roller can pull falling down magnetic minerals towards it. We can separate. Non-magnetic minerals just fall directly down. Magnetic separation. Right. Now, we are going to highlight certain things in these techniques. Right. Okay. Under mechanical methods, there are many. If MCQ question paper has asked like this, which of the following is not a mechanical separation method? You should know these are mechanical. Okay, something else can be given with 3 of these. And the most important one, as I feel, the last one here, highlight magnetic separation. Magnetic separation, එක ටිකක් advance. Magnetic separation. Then highlight separating certain minerals from mineral sand. Separating certain minerals from mineral sand. Highlight that part. Right? Okay. Then we come to last column, physical property used, physical property based. Let's highlight there these words. First one, densities. Densities. In the second one, size of particles. Size of particles. In the third one, no need to highlight, because once again it is densities and we have already highlighted. Third one, again densities, no need to highlight. Fourth one, densities, no need to highlight. Last one, magnetic property, highlight that, magnetic property. So these are the 3 physical properties used in separation methods, mechanical separation methods: density difference, particle size difference, magnetic property difference. Got it? Harine? Right, particle size, density, magnetic property are the ones used again and again. Right, that's the end of simplest one, mechanical separation. හරිද? ඔන්න 8න් එකක් ඉවරයි mechanical separation. Physical properties are used like density difference, particle size difference, magnetic property. Right. This second one, don't read, just look at the name of it. What is the name? And before that, look at this also, magnetic separation technique using machine. जो कहते हैं यार ඔක්කොම ටික ඇති ඈ, belt එකයි magnet everything ඇති ඔය ඇති. Right. Don't read. Vaporization, evaporation. එච්චරක් බලන්න. What is it? Vaporization, evaporation. Simply vaporization means what? Vaporization. Something turning into vapor. Yes or no? Yeah. Privatization means පෞද්ගලිකකරණයද මොකක්ද නේ? Right? Vaporization, turning to vapor. Evaporation then? Evaporation means simply it's like same. Evaporation means simply like there is a liquid, we supply heat, liquid turns to vapor and vapor evaporates. Vapor starts going up because of low density. Right, similar. Now I have a very clear question to ask. Hari. See whether you are clear about this. Right. Using salt water, our country, we separate salt, not water. But in some countries, bottle of water is expensive than bottle of petrol or diesel. Why? Because their ground has petrol, diesel. They don't have water. Such countries separate from sea water what? Water. Therefore, what is expensive? So once again, some countries separate salt from sea water and some other countries separate water from sea water. Right? So when we take sea water as the unit, when we separate water from this sea water, water from this sea water, is it vaporization, evaporation? Or sometimes we separate salt from this sea water, is that vaporization, evaporation? Both can't be, it should be one. Because when we heat, water boils and evaporates. We collect it, we collect vapor and we get water, pure water. Is that vaporization, evaporation? Or when we heat sea water, water evaporates, salt is left. We collect that. Is this vaporization, evaporation? What do you think? This point is going to confuse you. So it's okay now, but not exam day. So you have to solve this. We take sea water, we heat, water evaporates, we can collect water vapor, we can get pure water. Is this vaporization? Or when water evaporates out, salt is left, we collect salt. Is this evaporation, vaporization? Which one? You have to be clear. හොඳට නිදි කට්ටියනේ එම්බෑ පණේතෝ කියන්න ඕන. මොකක්ද ඔයගොල්ලෝ හිතන්නේ? හරි මං ආයේ I am going to be specific now. We heat seawater. Water evaporates. We collect, cool, and we get pure water. Is it vaporization, evaporation? එළියට යන සිංහලෙන් කියනනම් මුහුදු වතුර ලුණු වතුර රත් කරාම වතුර වාෂ්ප වෙනවා. වතුර ටික එකතු කරලා සීතල කරගන්නවා වාෂ්ප ටික එකතු කරලා. ඒක නෙවෙයිද vaporization? එහෙම නැත්තම් salt ඉතුරු වෙනවා salt. ඔය salt ටික ගන්නවා. ඒක වෙන්නේ නැද්ද vaporization? First one or second one? First one, right? No, wrong. First one is wrong. See, the name itself, name confuses us. Vaporization means collecting vapor. No, not vapor. Ne? නමට මෙයා වෙන්න එපා. දැන් සමහර ඉන්නවා මේනේ. යාර චූටි මැණි කේස් චූටි මැණි කියලා ඉන්නවානේ. නැග්ගියොත් ස්ටේජ් එකට කඩාගෙන වැටෙනවා. ටොන් 5ක් විතර බරයි. නම චූටි මැණි කේ නේ. සුදු මැණි කියලා ඉන්නවා. සුදුයිද? අප්පු. මූණ බලන්න බෑ කළුයි. කොහෙද දන්නේ සුදු. හරි. හැබැයි සුදු මැණි. හැබැයි කළුම කළුයි. ඔය වගේ ඈ. Vaporization is not taking vapor. Vaporization is we vaporize and remove unwanted things and the remaining part is collected. This is vaporization. පරිස්සමෙන් අපිට හිතෙන්නම according to the name vaporization නේ vapor නේ we use vapor. No, here vapor is allowed to go out. Okay, unwanted component is vaporized and the amount and then the component left is collected. Then what do we call that? තරහ වුණාද දන්නේ නැහැ චූටි මැණි කියලා සුදු මැණි කියලා නේ. මට හිතුන්නේ නැහැ ක්ලාස් එකේ නැතුව ටිකක් පරණ නම් නේ චූටි මැණිගේ සුදු මැණිගේ ඉස්සර කාලේ නම් නේ. දැන් මොනවද දාන්නේ? අලුත් නම් මොනවද? අලුත් නම් කට්ටියට තියෙන හරි. මේ got it? So my question is, then when we heat seawater, water vaporizes. This water, of course, we collect. What is that technique? It is your number 7. What is number 7? Distillation. Because this evaporating component is called distillate. Okay, evaporating part is called what? Distillate. So collecting distillate is called distillation. Okay, clear? Next time don't say then vaporization, evaporation, we take vapor. No, you have to be very clear. Otherwise, you think that yes, it's vapor because name is vaporization. ඔයාට ගෙදරට කියන නමක්වත් කිව්වද මම නැහැ නේ. අප්සෙට් එකේ ඉන්නවා full. හරි. Vaporization, evaporation. Got it? Right. So we can quickly read and finish it. So you know, in vaporization, what do we do? When there is a mixture, when there are one or more things ready to evaporate, boiling point is low, we heat. They boil and they evaporate. They go out. We don't care. That's what we want. And the remaining component is taken. It is when we produce salt from seawater and it is when we produce sugar from sugarcane juice also. Right. Vaporization, evaporation. But some of these techniques, more than one technique we discuss here from 1 to 8 are applied in extraction of certain things. Okay, in extraction of certain things. Now this vaporization, evaporation going very closely with crystallization also, going very closely with distillation also. That's why we have to know exactly what is this, what is that. Vaporization, evaporation. What is the meaning of this slash? You can use the word vaporization, you can use the word evaporation. Don't think that this is vaporization divided by evaporation. Like mass divided by volume, moles divided by volume, same name, same meaning. Right. During vaporization, unnecessary components are vaporized by supplying heat to a mixture and essential component is isolated. Okay, let's highlight unnecessary components are vaporized. Unnecessary components are vaporized. හරිද? ඕනේ දේව තමයි වාෂ්ප කරලා යවන්නේ අපි. Right. Example, extraction of salt from seawater, discuss later. Extraction of metals using amalgam. What is this amalgam? Amalgam or amalgam? Amalgam or amalgam, whatever. Hari? Amalgam. So, what is this amalgam? Something like chewing gum, bubble gum, kabhi kushi, kabhi gum. Right. Amalgam is something like this. Now listen carefully. Maybe you know, when we do laboratory experiments with mercury, we never keep gold jewelries here, because if mercury touches gold, it can melt gold, it can melt, it can dissolve gold. So, this way, when metals got mixed with gold, we can call it, metals got mixed with mercury, we can call it amalgam. Harida. So, amalgam is metal and mercury. So, gold mercury amalgam is there, silver mercury amalgam is there, several metals can form amalgams. So, this amalgam is used in metal extraction. How? Very simple. Say, මොනවද කිවි hina වෙනවා ක්ලාසික කියලා කියන්නේ නැහැ මොනවා කියලා hina වුනේ කියලා මේ හරි say we want to extract gold is mixed with various other things. We can add mercury and then we can dissolve gold in mercury. Now, where is gold? In mercury. We can separate this gold mercury amalgam. Then we evaporate mercury. What is left? Gold is left. So, this way amalgam is used in evaporation. Right, let us read and see, as is very simple. Amalgam. An amalgam is an alloy of mercury with another metal. Almost all metals form. Okay, wait. What is this word alloy? Is this alloy? Is this alloy? Is this alloy? Is this alloy? Alloy is ALOE. And aloe has another one part. What is it? VERA. Aloe vera. What is this aloe vera? Aloe vera. Aloe vera is comarica. Right? This is alloy. When we mix metal with another metal or metal with a non-metal, we can call it alloy. Harida. On alloy kinaka vistara kara hai. Right. So, an amalgam is an alloy of mercury with another metal. Almost all metals form amalgams with mercury. The notable exceptions are iron, platinum, tungsten and tantalum. You don't need that line. You don't need that part. You can cut and remove even. Silver mercury amalgams are important in dentistry, and gold mercury amalgam is used in extraction of gold from ore. In metal extraction, metals are dissolved in mercury and then mercury is evaporated. Impure gold is dissolved in mercury and form gold amalgam. It is a solution, then it is heated. Mercury evaporates and pure gold remains. See, mercury evaporates. Unwanted mercury is evaporated and is removed out. Then what is that technique? Vaporization, evaporation. Right. Evaporated mercury is cooled and used again, because mercury is toxic, mercury is expensive, mercury is valuable. But what we really need here is the remaining gold. So, this is not distillation, this is vaporization, evaporation. Harida boil karala apita ඕන නැති දේවල් වාෂ්ප කරලා අයින් කරලා ඕන වෙන දේ ඉතුරු කර ගන්නවා නම් ඕකට කියනවා vaporization. වාෂ්ප වෙලා යන දේ නෙවෙයි ඕන, ඉතුරු වෙන දේ තමයි ඕන. Vaporization, evaporation. Right. Now, I didn't describe one thing. It is silver mercury amalgams are important in dentistry, and you can see a photo also there. Filling teeth cavities using silver mercury amalgam. Why? Say there is a tooth cavity should fill this. What can be used? Cement, plastic, rubber. We have to have something strong, something long lasting, and something which never reacts with our body parts, with our body fluids, with our body simply. So, can we use iron? We can use iron. Next day when you open your mouth, you can see rusted. අර පුරෝප එක මලකට ගාලා තියෙන්නේ. අයන් වගේ එකක් බෑ. Zinc බෑ. Zinc is very reactive. Copper also can't. Aluminium Aluminium also can't. If you drink, after drinking something like Coca-Cola, you can see bubbles from that filled teeth. Why? Zinc is there, reacting. Aluminium is there, reacting with acid. So you have to use something very less reactive. Gold is okay, but gold is very expensive. When you sleep, someone will cut your neck and take the head to take gold out from teeth one by one. Gold can't. Silver is okay. Silver is cool. Color also is pleasant. Not reacting with anything easily, and not very expensive also. So silver is okay. Right now silver is okay. Now there is a problem. Silver is a hard solid. How can we put this silver into irregular shaped cavity? Maybe we have to make the cavity regular first. Cavity එක නිකන් එක shape එකකට හදන්න වෙනවා. Then we can keep silver piece there and we can hammer into tooth. What to do? You know, dentists, they clean our teeth cavity and remove little more also, and they make it fresh. Then it is irregular in shape. Then they use silver mercury amalgam. Amalgam makes silver very soft. Then I think you have experienced this. Using a special tool, they push a cement into our teeth. This side, that side, this way, they push something into our teeth cavity. What is it? Amalgam. So as amalgam is soft, they can push it into our irregular shaped teeth cavity. Later, mercury must be going out, right? Or maybe still there. It's okay, right? So this is the use of mercury, silver, amalgam in dentistry. Harido. That's the end of our vaporization, evaporation also. So what are we going to collect there? Evaporating thing or remaining thing? Remaining thing. If we collect evaporating thing, it is called distillation. It is called distillation. Our seventh one. Hi, bite එක වැටෙනවද බිමට? අවුලගෙන කන්න දෙන්නේ? නෑ පෙන්න එක නේ. චුට්ටක් ලාවර නිදාගත්තා. දැන් හරියනේ නිදිමත ගියානේ. චුට්ටක් නිදාගත්තා. Right. Third one is filtration. Already we have finished one filtration inside our body, which happens millions of times. What is it? Right. Blood filtration in kidneys. One kidney has about 1 million nephrons. So what is this filtration? This filtration is very simple. When we want to filter something in a school lab, we don't have any filters, but we have funnels, we have filter papers. Filter paper we fold like a cone like this, and we place inside the funnel and we pour our mixture into this. Filter paper has a small size holes. Through them, the smaller particles can go, large particles can't go. Very simple filtration. So what is the technique used here? Difference in particle sizes. The small particles can go, large particles can't go. So this way we take a filter paper, we fold it into two, into four, then we make a cone and we place inside the funnel, and this way using a glass rod, a long glass rod, little by little, little by little, little by little, we pour it into our filter paper. Then it would block all the holes at once, right? The part going is called filtrate, like our glomerular filtrate, which is later called urine. Filtrate is going. Remaining part is called what? Residue. Remaining part, residue, right? We don't just pour it into this one. These sediments will block all the holes at once. So little by little, along this glass rod we can pour it. Right. Glass rod, filter paper is here, funnel, filtrate, flask, residue remains, mixture of water, salt and soil, any mixture can be used, and this is the beaker. Very simple, right? Let's read and finish that. Filtration. Ready? The substance left in the filter is called residue. Highlight left residue. Left කියන්නේ වම් පැත්තේ නෙවෙයි, left කියන්නේ ඉතුරු වුණා. Highlight left residue. එතකොට right නෙවෙයි. The going part is filtrate. Second line, the solution that gets filtered is called filtrate. You can highlight gets filtered, filtrate. Right, then come on, need your attention. Let's finish it now. May දැන් ඉවර කරමු මේ වැඩේ. We fold the filter paper in a special way and place inside the funnel. We pour the solution and then filtrate passes through the filter paper. Residue remains on it. Right. Okay. Now something special. In water purification plants give trees never, machines, right? Machines and factories. In water purification factories, machines, plants, sand filters are used to remove clay and silt particles and other sediments. So, water has many floating things. Sometimes grease is there, organic matter is there, plastic particles are there. All these sediments can be removed using sand filters. Sand filter means nicely washed, fine sand particles. Through this sand, we can send water downwards or even upwards. These sand particles keep all the sediments and making water much better. Maybe you have done this activity when you were in grade 2-3. In grade 2, 3, 4 kale, we take a plastic bottle, we make some small holes in the bottom and we fill it using washed fine sand and then we pour mud water. After few minutes you can see mudless, I can't say mudless, but much better water coming out through those holes. So, sand is a good filter, a small activity. Right. Then next one, little more advanced. Ion exchange materials and activated carbon also used in advanced filters. Now, what are ion exchange materials? What is activated carbon? Ion exchange materials are some materials which can exchange ions. Exchange ions means they have the ability to absorb, take and keep on the surface harmful ions present in water, and in return they have the ability to release, discharge non-harmful ions into water. So, this is called ion exchange. Okay. So, we make some towers located very close to each other using these materials, and we pass a slow stream of water through these gaps. Then what happens? They touch these towers nicely, and these towers take harmful ions and retain on the surface and release less harmful, non-harmful ions to water. This is called ion exchange. So, after filtering some amount of water, these towers lose the ability to exchange ions. Then we have to replace these using new towers. These are called ion exchange materials. හරිද? වතුරේ තියෙන harmful ඒවා ඒගොල්ලෝ අරගෙන තියාගන්නවා. less harmful ඒවා වතුරට දානවා. non harmful ඒවා දානවා. So, time to time we have to replace this filter set, this filter part. Even in purette we have to do ne. Germ killer set එක time to time we have to replace ne. So, surely these techniques are there. Ion exchanging materials. Right. Next one, ion exchange materials absorb harmful ions. Absorb? No, not absorb. What is it? Adsorb. Adsorb means taking onto the surface, not in, and retains on the surface. Adsorb. හරි පාර යන කෙනෙක් අහන පොඩ්ඩක් ගෙදෙට්ටෙන් දෙක ගේ අතුරට ගන්නෑ. දොර ළඟට විතරයි ගන්න. වැඩේ කරලා යවනවා. absorb නෙවෙයි adsorb. ෂුවර් නෑ අතුරට ගන්නෑ. හරි ගේ අතුරට ගන්නෑ. absorb නෙවෙයි adsorb. හරි adsorb. Right. That's called adsorb. So, what is this? Adsorb. Right. Ion exchange materials adsorb harmful ions present in water onto them and release non-harmful substances to water in return. Right. The last one, activated carbon. So, when this activated carbon concept came, all people thought, we also thought that activated carbon means like carbon atoms which are very active, like which can dance, which can jump, which can fight with germs to kill them. but not. Right? We all thought that activated carbon means like very active carbon atoms who can fight with germs and can kill germs. No, 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 no. Activated carbon means some structures made using carbon with lot of tunnels, holes like this. Look at this. This is the surface photo. May bana me peta. ඕක නෙවෙයි activated carbon මේක මේ හරි මෙන්න activated carbon second photo. You can see white color material, white color part is the wall, black color parts are holes, tunnels. In the cross section you can see there are deep tunnels in this activated carbon material, and in these tunnels, in these cavities, small particles, large particles, small germs, large germs, everything I can't say absorbed, but everything retained inside this, passing clean air through it, clean water through it. Activated carbon. Hurry. So activated carbon has cavities, large, small, different sizes, different shapes. In these cavities unwanted things stay, and clean air, clean water, or the clean material, only clean material can go. So after some time this also we have to replace, or we have to clean, or whatever. Activated carbon, right? So you learn two things new here: ion exchange materials, what they do, and activated carbon. Let's read about activated carbon. What the point is yes, a phone nigga. A Pathagindian killer away. Bagging a Pathagindian Mado pain on Angarindian. I got the way. I pay Negol Monohari, Choti Manico Bello than a phone, Sudumani and other, Choti Mani. Okay. Now anyway, let's use these 2 hours to finish this. Hurry. Now take, put into your head, record, finish everything. Hurry. Next one. We didn't read about last one, activated carbon. Activated carbon has cavities of different sizes to retain harmful substances in them without passing. Say water has harmful substances, all retained here. Clean water can go. Say air has harmful substances like coronavirus and all, they stay. Clean air can go. Right. Filtration, finish. Okay. White packet chewing gum, amalgam, what? Something. Crystallization. Very serious, eh? Crystallization. So after 1 year I am teaching crystallization. Crystallization. Right. In crystallization what we do is, listen carefully, in crystallization what we do is, we make crystals of something. Something dissolved is converted to solid, crystallization. Example, in salt and also this happens. See, water has salt dissolved in water, and we convert this dissolved salt into crystals. Crystallization or not? Crystallization. But how? By evaporating the solvent, and evaporating solvent, getting what is left has another name. What's that? I told you, then few minutes ago I told this. In Salton, water is evaporated, salt is left. Now we say in Salton, salt crystals are made by removing evaporating water. So now we call this crystallization, because crystals form. And few minutes ago we call this what? Evaporation also. Why? Unwanted water is evaporated and salt is left. Now salt crystals form because of evaporation of water. Now this is crystallization. So in Salton, when they ask you to write the technique used, there are 2 answers. One is evaporation or vaporization, one is crystallization. Right. So we are talking about what now? Crystallization. Crystallization. So to understand this crystallization, I am going to use a simple diagram. For the diagram I use crystallization. Hari මෙයා තමයි යෝනේ අපි අඳින්නේ. Crystallization. Two colors not enough. Right, let's use three colors. Red, blue, black. Crystallization. Now you have to involve in this actively. May then ඔලුවට ගන්න ඕනේ. වැඩේ ඉවරයක් කරමු. This is not to take notes. Go home and read. We finish it now. Right. Crystallization. There is container. Right. Say there is a container. මෙහෙම තියෙනවා container එක. Later you have to draw this, but not now. Not now. Not now. හරි. Container. Container. Container, right? This container has solvent. Say it is water. Hurry, water up to this level. Water up to this level, and some salt also. චුට්ටක් මේකේ තියෙනවා salt also, red color. Hurry, salt. Hurry. Assume that is 1000 salt. Salt, I can't say molecules. Salt is ionic compound, no? So I can't say 1000 molecules. Say 1000 units are there, and 10,000. නිකන් හිතමු 10,000 here. 10,000. We heat this one. Compound. Boiling point is very high, but water can evaporate because water's boiling point is low, 100. With this, solvent evaporates, water evaporates. Therefore, amount decreases. Say water amount is now this much, about half. Salt amount is same. Say same. Say 5,000. And if we assume that solubilities, what is solubility? The amount of solute soluble in 100 grams of the solvent. Hurry. Say salt. We need minimum 5,000. Let's to dissolve. Assume करूँ मैं to dissolve 1000 salt. If we assume to understand 1000 salt, we need 5,000 water. Just assume අපි නිකන් හිතමු to dissolve 1000 salt we need 5,000 water කියලා. හරි. Now 5,000 water is there and salt is 1000. Is there any issue? No issue. Water is enough to dissolve all the salt, and can we dissolve little more salt in this now? Can we dissolve 1001? Can't, because water 5,000 and salt maximum is 1000. Got it? Maximum salt amount is dissolved now. No more space. Solvent has no more space to keep solute. This situation is called saturation. It is which has maximum concentration by dissolving the maximum amount of solute. Can't dissolve any more. 1 milligram even can't dissolve. If you can dissolve, still not saturated. Hurry, or not saturated. Right, now this is a saturated solution. Now what happens? අපි කරොත් මොනවා cool කරොත් cooling වෙන්න ඕනද? You know, when temperature is going down, solubility of a solid also going down. Solubility of a solid is high when temperature is high. In hot water we can dissolve more. Okay, and you know, heated this is a hot saturated solution. We heated it, no, so this is hot. This is a hot warm saturated solution. If we cool it, what happens? Solubility decreases. Now can 5000 water keep 1000 salt particles dissolved in it? Now can't. Okay, if this solution is saturated, we know it is a hot solution. It is saturated. That means maximum amount 1000 is there in 5000 water. Now we cool this. You know, when we cool, what happens? Solubility decreases. That means ඔයා පොඩ්ඩක් එහා පැත්තෙන් වාඩි වුණා. තව චුට්ටක් එහාට යන්න. යන්න කිව්වම මම දැන් කීප සැරයක්ම නෝට් කරන්න. තව පොඩ්ඩක් යන්න. නැනෝමීටරයක් ගිහිල්ලා මදි. තව පොඩ්ඩක් යන්න. තව චුට්ටක්. හරි. හරි. ඒ ඔයාටත් හොඳයි අනිත් අයටත් හොඳයි. මෙහාට එන්න බෑ. දැන් ඔන්න when we cool, what happens to solubility? Solubility decreases. ඕන් එනවා. දැනටම දෙපාරක් විතර ionic compounds වගේ නේද නිකන් අර attraction. Okay. මේ ඔන්න දැන් once again disturb වුණා. When we cool, solubility is low. That means now cool 5000 can't keep salt 1000. Some amount of salt has to go out from water. So can salt jump? Can salt evaporate? Salt has only one solution. What is it? Salt has to go out from the solution. That means salt has to become solid. Going out from the solution means not going out from the container. Going out from the solution means solution is liquid, no? It can turn to gas or it can turn to solid. So it turns to solid. What happens? මොනවද වෙන්නේ? දැන් අපි මේව cool කරාම. When we cool this warm saturated solution, solubility decreases. When solubility decreases, some amount of salt turns to solid form. That means crystals form. What do we? Crystallization. Then ඉතින් salt can't stay dissolved fully. Some amount of salt has to go down. මෙයා ඇත්තටම salt crystals නේ. Crystals of salt can be formed. But of course, in this water, 5000 water, some amount of salt can stay dissolved also. හරිද? නිකන් මෙහෙම හිතමුකෝ. හරි. We cool it. This has salt dissolved, say 900. 900 dissolved. Crystals of salt, say 100. When you add 900 and 100, once again 1000, no? Once again 1000. Right. So this way, crystallization can be done. How? We make a hot saturated solution and we cool it. Okay, we prepare a hot saturated solution and we cool it. When we cool it, solubility decreases, some amount has to go out, not out, go down in crystal form. This is crystallization. Okay, can't we heat and do this? If we heat, what would happen? If we heat this, what would happen? Heating. It also can come, no? Because in salt and no one is going to cool, no? කවුරු හරි රෑ 12ට විතර කියලා salt එකනේ cool කරනවද? During the daytime it is getting heated, not cooling. But it's happening, no? Yeah, then we have to know that too. If we heat, what happens? Tell me, if we heat, what happens? If we heat, first saturated solution can become unsaturated solution. Why? Solubility increases. Solubility increases. When we heat this little, 5000 water can keep greater than 1000 salt in this. Why? Solubility increases. But with that, water starts to evaporate. Water also starts to evaporate. Then water volume decreases. When water volume decreases, Can this water keep 1000 now? No. Now also crystallization occurs. Now also crystallization occurs. So, by cooling of course we can do, by heating also practically we know we can do. According to syllabus also we can do. One last time. We heat this saturated solution. When we heat it, solubility increases, therefore first this becomes unsaturated. That means you can dissolve more salt in it if you want. Solubility is high now. But with this, water evaporates continuously, reducing the volume. Then there is no 5000 water. Now water is like 4000. Now can it keep 1000? Now can't. Then also crystals. Okay, right. So it is like this has water still 5000, but this has no water 5000. Now it's like water 4000. Therefore, can't keep salt dissolved 1000, some amount crystallizes. Right. So what is the best way? Cooling saturated solution. But heating also possible. But there's a problematic situation. What? A little, you can't get crystals. You have to cool, when you heat a little, you can't get crystals. You have to heat a lot then. But if you are cooling, even when you cool a very little, crystals form. හරිද? සීතල කරොත් පොඩ්ඩක් සීතල කරත් ක්‍රිස්ටල්ස් වලට හැදෙන්න වෙනවා. රත් කරොත් ගොඩක් රත් කරන්න වෙයි. ඒ නිසා අපි බෙස්ට් මෙතඩ් එක මොකද්ද? Cooling a hot saturated solution. Right. So that's the story. There's a definition also. Let's go and see. Crystallization. Crystallization occurs in a saturated solution. That's the first thing. Then what is a saturated solution? Saturated solution. When the maximum amount of solute is dissolved in a solvent, it forms a solution with maximum concentration. We cannot dissolve solute any more in it, anymore, can't. Therefore, its concentration cannot be increased anymore. Right. This is our new syllabus definition for a saturated solution. What is it? A solution which has the maximum concentration of a solute in it. Highlight it, remember. Old syllabus definition was not this, but idea was same. New syllabus definition is this. Come on, packet එක ඉවරයිනේ. ඒක තමයි නිදිමත. හරිද? Right. Saturated solution is, highlight, a solution which has the maximum concentration of a solute in it. මතක තියාගන්න අහන්න පුළුවන් what is a saturated solution. Even in MCQ paper 4 answers can be given. Right. Inside brackets, when maximum amount of solute dissolved, this happens. Right. Then what occurs when we heat a non-saturated solution? Non-saturated one. Solvent evaporates. Volume of solution decreases. Therefore, its concentration increases and it becomes saturated. If we evaporate the solvent after that, then the solute separates out, forming crystals. It is crystallization. If we heat a non-saturated one, first it becomes saturated, then crystals form there. Right. Now, next thing you should learn by heart is crystallization is. What is a saturated solution? You have to remember. What is crystallization? You have to remember. This is new syllabus definition. Method of separating solid substances by concentration. Method of separating solid substances by concentration. When a solute that can turn into a solid is present in the solution. When a solute that can turn into a solid is present in a solution. That means in the solution there is a solute dissolved, but it is okay, it can turn into solid. Then we turn into solid by increasing concentration. This is called crystallization. So remember, highlight and remember that also. අහන්න පුළුවන් what is crystallization? Usually they don't ask. Hari? Usually they give this statement and ask you to write the name of this. Then we write crystallization. But who knows, can come the other way also. Right. Now Applications, examples of crystallization. Number 1, producing crushed sugar cane. It is one. Producing sugar by heating the juicy solution of crushed sugar cane. See, we are not cooling it, we heat it and get crystals. Harida, though our laboratory method is cooling, we don't do it actually. In salt and also we don't do, in sugar factory also we don't do. Second one, producing salt from seawater by evaporating water using solar energy. Now remember, you can highlight even sugar, salt. You can just highlight sugar, salt. When we make sugar, we do this. When we make salt, we do this. Right. Now we are going to this way. Volume high. Some salt. Let's put now heat. Volume decreases. Salt same, water is about half. Now this is saturated. You can heat it, you get less water and then you get salt. You cool it, you get same water, you get salt. Right? With these numbers, mark this nicely. Saturated එක්කෙනා රත් කරොත් water අඩු වෙන හින්දා crystals හැදෙනවා. Saturated එක්කෙනා cool කරොත් saturated එක්කෙනා water ඒ ගානව තියෙද්දි crystals හැදෙනවා. Because solubility decreases. That's the reason, right? Please use 2-3 colors, mark it nicely. Now itself, take it. බයිට් එක ඉවරයි. අදිනේ. ෆෝන් එක මිසින් දෙපාර. අතන තිබ්බ එක අතිනවනේ. එහෙනම් කොච්චර ආසද අපි කොල්ල සෙට් එකෙන් වැඩි හරියක් ඒ දා ගන්නවා නම් හරියන පොඩ්ඩක්. ළඟනන්න දෙන්න බෑ. හරි තාම උනන්දුවෙන් කරමු. මදි මොකුත් ලියලා නැහැ. ඉක්මනට. හරිද? We finish it now, right now. When we complete 2 hours, should be in your head. Can. You can write heat or you can write heating, you can write cooling, it's okay. Like saturated is like, say there are 100 chairs, 100 people can sit. Saturated, not anymore. Maximum concentration. Cooling is like you are removing some chairs out. Since some people have to sit on the ground, crystallization. Dada ambima. Oy okay. Heating is like you heat and evaporate some chairs. Then also people can't sit. They have to sit on the ground like that. Solvent should be there to dissolve solute. When solvent is not enough, solute can't stay dissolved. Solute has to turn to solid form. Then it is crystallization. Isn't it? Amount of solvent has maximum amount which it can dissolve. After that, can't dissolve anymore. Saturated. Right. Enough. Crystallization. Now, these are nice, interesting stories. Right. Crystallization. After this diagram, right? Activity to study crystallization. Activity to study crystallization means something we can do in the school lab to study crystallization. Right. Number 1, dissolve crystals of salt in hot water. Why hot water? Because we can dissolve it well. No, we are going to cool it, that's why. Cool water we can't cool anymore, no. So we use hot water. Right. Dissolve crystals of salt in hot water and make a hot saturated solution. Filter the hot solution using filter paper. Why should we filter? Tell me. Ayoga filter karanna one. That's a practical problem. That's why. What's a practical problem? We prepare a saturated solution by dissolving salt in water. We get to know that it is saturated when some amount of salt is left undissolved. Otherwise, how do we know it is saturated or not? Will solution shout, I am saturated, stop dissolving? We get to know that it is saturated when we can't dissolve any more salt. To make it sure, we add little more salt and we try to dissolve, can't dissolve. Now crystals are there, no? And it is like crystallization, no crystals are there. So we have to remove these crystals, that's why we filter. Now no crystals. Right? අපි සැචුරේටඩ් කියලා දැනගන්නේ කොහොමද? තව දිය වෙන්නේ නැති වුණාමනේ. ඒ කියන්නේ දිය වෙන්නේ නැතුව ඉතුරු වෙලා තියෙන්න ඕන. දැන් ওই ටිකත් ක්‍රිස්ටල් නේ එතකොට. ওই ටික අයින් කරන්න ඕන. That's why we filter. Right. Then it's just a solution, no crystals. Right. මට නිකන් thanks කරනවා වගේ මේවා පොඩ්ඩක් ඈඩ් කරලා දුන්නාට දැන් අහන් ඉන්න පුළුවන් හොඳේ. I'm joking. හරි. අහන් ඉන්න. Right. That's why we filter the solution using filter paper. Third one. Take the filtrate into a beaker. Now it is warm still. Place it in a container of ice and shake slowly. Observe the crystals formed. Right. So this way, when we reduce its temperature, crystals form. Right. This is how we make. Very simple, but can ask. Simply, they can ask you to write an activity used to observe crystallization in 3 steps. Why 3 steps? 3 marks. That's why. 3 steps වලින් ලියන්න කිව්වොත් දෙන්නේ 3 marks එකයි. If they ask you to write in 2 steps, they are going to give you 2 marks. That's why 2 steps. Okay, so this way we can study. So according to our syllabus, what is the way of observing crystallization? Cooling a hot saturated solution. But both practical examples are not coolings. They are heating sugar solution, heating salt water. But now you can understand both because I covered both here. What happens when we cool, what happens when we heat. Right? Okay. Now next one. Immediately we should do it today itself. Recrystallization. Crystallization madivata. Recrystallization. What is recrystallization? Read karanne recrystallization. Like recharging. Recrystallization. Recrystallization means like this. Look at this. Recrystallization like this. We found crystallized something. We find crystallized something. Crystallized has color sodium chloride. Say this has black color sodium chloride 95%. And this has everywhere mixed well and impurity. Impurity, say it is 5%, magnesium chloride or something. We want to get pure sodium chloride. We do recrystallization. Already crystallization occurred, but bad. So we do recrystallization to get pure crystals. How to do that? Katandare harida. Already it is crystallized, but bad. Impurities are there. We don't know where. We want to remove. So we do recrystallization. Recrystallization is this. We dissolve these impure crystals in a suitable warm solvent, and we make a saturated solution, and we filter it and we cool it. Okay, these crystals are dissolved in a suitable solvent to make a saturated warm solution, and we filter it. Now it's a saturated warm solution. When we cool this, exactly like last time, crystallization occurs. It is called recrystallization. But this time these crystals are only with this one, not with this one. What's the reason for that? When we dissolve in the solution, when we dissolve in the solvent, impurities are very little in it. See, impurities are like 5%. So in that warm solution, impurities are just here and there, not everywhere. It is very little in amount. So can it become saturated in the solution? Saturated means what? Maximum amount is dissolved, lot is dissolved. Once again, these crystals have two things. One is what we want, say 95%. One is what we don't want, impurities, say 5%. 5% means nothing. Like say you get 5 marks for science, that's 5%. Nothing. So impurities nothing. So in this saturated solution also, impurities are very little. That means, are they saturated? No. If they are not saturated, can they form crystals? No. Why? Crystallization occurs in what solution? Saturated solution, don't forget. So what is more can become saturated in the solution, can make crystals. What is very little can't saturate the solution, can't form crystals. Crystallization occurs in which solution? Saturated solution. Saturated means what? A lot, maximum is dissolved. Yeah, what we want is saturated, what we want is maximum there, but we don't want is very little there. Therefore, can this crystallize again? No, no, this can't. Crystallization when a saturated solution එක saturated කියන්නේ උපරිමයි දිය වෙච්ච එක. ඉතින් උපරිමේ දිය වෙලා නැහැ නේ මෙයා චුට්ටයි ඉන්නේ. චුට්ටයි ඉන්නේ. එහෙනම් එයාට පුළුවන් ද crystallize වෙන්න? බෑ. එයා ගොඩාක් ඉන්නවා. එයාට පුළුවන් crystallize වෙන්න. This way, when we do recrystallization, we get pure crystals. Impurities can never form crystals again. Why? They are very little in the amount. On a recrystallization. Right, let's read and see. If you have, right? Right. Recrystallization. This is a method used to separate pure substances from solid crystalline substances mixed with impurities. Right? This method is used to separate pure substances from solid crystalline substances mixed with impurities. So we are getting crystals again from already crystals, therefore this is called recrystallization. What is recrystallization? Possible. The process of dissolving a solid crystalline substance with impurities and turning it again into crystals. Good, you highlight and remember. What is recrystallization? Process of dissolving a solid crystalline substance but with impurities and turning it again into crystals. I really like to say into pure crystals, but book says into crystals. කියන්න පුළුවන් නම් into pure crystals කියලා ඔන්න නියමයි. But book එකේ කියනවා into crystals කමන්නේ. Into crystals. How is recrystallization done? Have to remember. I told you have to remember crystallization. How to do recrystallization. දෙකම මතක තියෙන්න ඕනේ. හරි. What's the first step? Impure solid substance is dissolved in a hot solvent till it becomes saturated. How do we know that it got saturated? Some amount is left undissolved. Then we have to filter it. Right. Second one, solution is filtered while it is hot. You can't say it is warm now, I can't filter, after cooling I filter, bad. While it is warm you have to filter. Why? Because you are going to cool it then. Last one, filtrate is cooled. When we cool it, solubility decreases and some amount crystallizes. ඔක්කොම නෙවෙයි, some amount crystallizes, some amount, but that amount is pure. That amount is pure. Right. Impurities cannot crystallize as they are little in amount and therefore cannot get saturated. Produces crystals with high quality which have no impurities. As a result, what we do is we dissolve impure crystals in a solvent and crystallize again. As a summary, what we do is we dissolve impure crystals in a solvent and crystallize again. Right. Essential amount or percentage of impurities should be low in the mixture. Otherwise, impurities also can crystallize again. හිතන්නකො 50% 50% or 60% 40%. Impurities also can try to crystallize, but now can't because they can